Example. The average price of a flat plasma television are shown in the table below for various years. So there is our tables which has years 2000, 2001, 2003, 2005, 2006. And also average price in thousands of dollars. 9.8, remember that's thousands, or in other words $9,800. 6.8, 4.6, 2.5, and 1.7. So let P be the average price in thousands of dollars of flat plasma television at T years since 2000. So notice the word since 2000. I highly recommend you read word problems at least twice. So the average price of a flat plasma television are shown in the table below for various years. So we have the years and the price. Let P be the average price in thousands of dollars of a flat plasma television at T years since 2000. Okay. Just a visual representation for you. There's a TV with the antenna box. Look at the mass travel through the antenna. Alright, so let's go to the next view for reference in this case. I've gone a little ahead of myself and basically converted our tables. So the question is, can this be modeled as a quadratic function? Well, you've gotten a chance to do linear equations more than likely, right? And now you're working on quadratic equations or quadratic functions. So the first thing we've got to do, just like a linear equation, change your years to singular values starting from the date it specifies. This will make your graphing a little bit easier and it'll fit in a smaller graph size. So years, since it started since the year 2000, we have the year 2000 on our table, right? So that becomes year 0. 2001, year 1, 2003, year 3, etc. So we have 0, 1, 3, 5, and 6 conversion. Notice the average price in thousands of dollars remains the same, so we don't change that. Only the years is what we converted to singular years to make it easier to plot. Agreed? So once again, only the years. So now that we got a chance to convert them, singular years, I went ahead and once again I did a quick sketch. Just like a linear equation, you can sketch a quadratic equation. Well, is this a quadratic equation or a linear equation? That's an excellent question, right? So you'll find out once you plot it. In this case I plotted it and this is what it looks like. So the question is now, is it a linear or quadratic? Okay, let's go to the next one then. There it is. What would you say? Does a linear equation fit it better or a quadratic equation? So I kind of overlaid both of them there for you. Your guess is as good as mine. Be aware of that. Sometimes your guess might be correct, your guess might be slightly wrong or completely wrong, depending on the case. From now on, it's depending on your point of view, how you explain it. Why do you think it's a linear equation more than a quadratic equation? Estimate when the average price of a flat plasma television was 5.7 thousand. So, just like a linear equation, linear graph, you're going to have to answer questions. And likewise, in this case, let's assume that the price P is in thousands of dollars. That's my Y variable representative. X variable representative is T, years. So let's answer the question first. And there's roughly 5.5 mark on the left side there of our graph. Now it's easier to visualize. We're looking for 5.7 and 5.7 thousand, right? It's roughly about there where you see the dashed line. It's roughly close to 5.7. We follow it back, just like you would in a linear equation, to our x-axis, and that tells us roughly 2.1, 2.2 years. But we would probably call it a full year, right? So it's 2 years. In other words, in the year 2002. By the year 2002, the price of a flat plasma television was 5.7 thousand, or in other words, $5,700. Whoa, can you believe flat plasma televisions cost that much? $5,700 for a plasma television. What can you buy today for that particular amount of money? I'll leave it up to you to define that. Let's assume we continue graphing our parabola, and it looks something like this, agreed? So there it is. So does the part of the parabola that lies to the right of the vertex describe the situation well? Notice on the left side, our parabola, or price of plasma television, was decreasing, agreed? To the right, once you go past your vertex, your parabola, or in other words, quadratic equation, eventually increases again. Is this a true statement? Can your plasma televisions go up again? Does this example fit the data well? It may not, right? So we haven't seen plasma television price increase. So we would assume that in this case, this area here is clouded. In other words, there's a model breakdown. Price would most likely not go up again, right? Unless you buy a antique. But in this case, we would definitely not see an increase for those particular years at least in the purchase of a flat plasma television. So definitely this would be model breakdown. So once again, you've done linear equations that are similar, but the only difference now you're using a quadratic equation form of graphing and explaining. Basically stating whether it is a good approximation or a bad approximation. That'll depend on your point of view.